After finishing the design, we need to divide the parts into smaller pieces with the proper dimensions for our 3D printer. For example, my 3D printer has 200 cubic millimeter volume of print, so I need to keep all the dimensions of these smaller parts under 200 millimeters. Also, these smaller pieces need some features to get a precise alignment and strong bonds after the print process. Step 1 is measurement. For example, this is the fuselage that we have, and I gonna print it from the bottom to the nose, and let's measure the distance between these two area, and that's 600 millimeters. So basically we can divide this part into 3 sections, but something that I recommend is to keep it smaller and do not go on the edge of your 3D printer limits. So I defined some planes. The reference is detail section, and I defined the offset amount for 180 millimeters. Flip offset and create another one and another one. As you see, we gonna have 4 separated sections. Now I need to create some sketch on these planes. I select the first one, section view, select it again, and start to create some sketch. I select the intersection curve, and add the surfaces one by one to create some sketch out of these surfaces. Okay. Now I'm gonna try to create some offset from these lines. Okay, I remove this and this to disconnect these lines and create the offset. I bring them back here by trying again on the intersection curve. All right. Now for this area, I create a spline and adjust it manually. Select this arm and make it tangent with the other sketch line. And doing the same for this one. The rest of the adjustment is by the length of this arrow on the control arm of the spline. Okay, Let's try to mirror this about this center line. So we got this error and I removed the mirror relation. Here, as you see, when I try to select the chain and the loop around the body, it fails to select the other lines, and we try to find the problem with that. So it's on the very tiny dimensions. Let's see if we are able to extrude this section without fixing that. So as you see, it's not able to recognize this area as a contour. So the problem needs to be solved. I quickly fix it manually again using spline. Again, make it tangent with the both sides of the sketch. If I keep this line inside the outer edge, it's okay and it won't be causing any problem, but I try to make it closer to the edge as much as I can. And mirror again. Okay, same error, same solution. And as you see, this contour between two sketches, between two loops, is recognized by the SolidWorks now, and we are able to create a bus extrude feature. I select mid-plane and 1 millimeter for the thickness. So let's disable this section view. As you see, we have some extra edges. By activating this feature here, we can add some tilt degree to the extruded feature to force it inside of the boundary that we have. So now we have a perfect surface and our section is inside. The result of that angle that I added is visible here. Let's move on to the next section. The process here is the same as the previous. Again, intersection curve, and we have it. Select chain, no problem here. Create offset, reverse, and done. We can close this and manually like this, or close it in the offset command. Okay. 1 millimeter again on the mid plane. Again, we have this excess outside the fuselage, and same solution. So the last one. Another offset, another extruded bus, mid plane, so this time, because of the sharper angle of the nose, I need to create it by two separated sketch, two separated feature. .5 millimeter in this direction. Doesn't need the draft angle. As you see, it doesn't create any excess on the outer edge. So I select and choose the sketch again for the another 0.5 millimeter in the forward direction. This time we need the draft angle. So it still creates some geometric failure around this area. So I deactivate this draft angle and remove the excess in another way. I roll back the design tree, create some offset surface here with 0 offset distance, activating this bus extrude again, and this time I use this surface to use the cut with surface command and remove the excess that we have. And here this arrow shows the direction of the cut. We need to cut everything outside this boundary. And now we have our smooth nose back with no excess. So these flanges are going to create that strong bond between the sections that we print separately, but to create that adjustment feature, I select the top plane and create another sketch here. Let me hide this surface. Intersection curve again. Okay, this face is all right. I reconnect these points again with the spline and make it tangent. I select the top plane and section view because I need to make sure that the offset that I create from this line is crossing the sections that we just created. This time 1.5. So it goes through this section, this one, and the last one perfectly. All right, now I create another sketch on the end of the fuselage. Here on this surface, and it is a circle with diameter of 1 millimeter, and make it pierce with this, so it's not possible. Coincidence. No, so I add the dimension from the other edge. It was 1.5 millimeter. Okay. Now I go to Features, Swept Cut. Here I select the profile of the cut, this circle, and the path of the cut is this line. So we got this error. Let's check the other options. The circular profile doesn't need another sketch as the profile, so I select this 1 millimeter, and let's check the result. So it cuts everything perfectly. And I mirror this cut around the right plane. And we do not need this sketch anymore. Okay, let's bring back these planes because it's time to divide and export sections. To do that, we go to the direct editing or features to select the split command trim tools are these planes. The target bodies, here we select all bodies, but actually we have just one body here. Select the cut. As you see, we have separated sub parts here, and we check this. We can select this here and save them with the custom name, but I just select the auto assign names to make the video shorter. Here the bodies that we separated from each other are available on the folder that we opened the file from it. So we have these flanges to create the bond and these holes for the adjustment. And actually we can use some wood stick or carbon fiber rods with the 1 millimeter of thickness to align them and even make the bond stronger. So as the example, I work the rest of the process on this file. If I print this from this section as the bottom and this section as the top, this flange here doesn't need any support, but this one gonna need something to make this flange print on. And I simply, by adding some fillets, solve the problem of that. 3 millimeters. Okay. The layers of print will hang on the fillet and they won't need any support material. I also do it for this internal edge here, this one. So it creates a little problem. I do not select it. So you just need to add these fillets on the one side, not both of them. So this file is actually ready to save it as STL file, export it to the slicer or any slicer that you use, for example Cura, and it's ready for the print process. So what about the wings and control surfaces? In this case, we just slice the wing and do not need any extra alignment feature because the carbon fiber tubes will do the job on the wings and stabilizers. That means you simply create some planes by selecting this surface. And just cutting the wing using these planes, we are done with the wing. And same situation for the stabilizers and control surfaces. I'm EK and you watch Dynamic Systems. You can support me in covering more topics by subscribing to the channel. Thanks for watching and see you in the next one.